All right, so after our talk about the one-to-one property in class today, after we went over the reviews, felt like I should maybe explain a little bit more about why you can't do what you're doing. I want to make sure that you understand that everything you do has a rule, a theorem, a property, something behind it that allows you to do what you're doing. It is not magic. You have to have some mathematical basis for it. So I didn't explain this when we went over it because the exponentials and logs are greatly a review for you from Algebra 2. The one-to-one property is something that should have been taught in Algebra 2 and we're just using it now. So, but if you look on your notes, well, you can look at these, you don't have to look at your notes, but on page 80 when we solved exponentials using a common base, here's where it talks about the one-to-one property. If b to the x equals b to the y, then x equals y. And that should make sense to you. So let's look at why that really works. It's important for you to understand the whys behind these things, so then you know, it helps you better know when to do what, and you don't just feel like you're randomly doing things. So if you have something that looks like this, 5 to the x equals 5 to the second. So we've done way more complicated ones than that. And you know at this point that x has to equal 2, which makes sense. It makes sense just from a logical standpoint, whether you understand exponentials or exponents or anything anyway. But x equals 2. Here's what is not happening, okay? Because I saw this in some of the work and it really bothered me because there is not a single teacher out there that would show you to do this. The 5s don't cancel out. That is totally not what's happening, okay? They don't, it's basically that means you're dividing both sides by 5. And that doesn't make any sense at all. So like if I had 3 squared equals 9, which makes sense, right? So if I divide both sides by 3, right? I don't cancel those out. And then I'm left with what? 2 equal, I don't even know what I'd be left with. Like if the base goes away, the exponent's just floating up there with nothing. So that is not what is happening. What's actually happening when you have this 5 to the x equals 5 to the second, or anything way more complicated than that, is in order to get the exponent out, the only thing that's going to get the exponent out of the exponent, or the variable out of the exponent, is taking the log. Well, I can take the log of both sides. I could use the natural log, I could use the common log, and I could still get to that point. But whatever my base is, if I use that log, so this base is 5, so if I take log base 5 of both sides, that's 5 to the x, that's equal to log base 5 of 5 squared, because here's your whatever you do to one side, you have to do to the other. So now we can use our exponent rules. This comes out, so I get x times the log base 5 of 5 equals 2 times log base 5 of 5. And then those, y'all seem to throw around the words, they cancel out a lot. Things don't cancel out. They cancel out when you divide, when you, when you add, subtract, or whatever. Nothing's canceling out here necessarily. I mean, yes, I could divide both sides by log base 5 of 5, but I don't need to. The reason I chose this base is that log base 5 of 5, let me write this out here, that log base 5 of 5 equals 1. So basically now I have x times 1 and 2 times 1, and that's why when I just 1 we don't write, and I get x equals 2. That's where that is coming from. You are using logs even though you're not using logs. So the one-to-one property is like the property, the theorems, they have been proven, they have been shown, and basically it's allowing you to skip all of these steps and jump from here to here. Without the one-to-one property, I would have to solve it in some fashion like this every single time, and we don't want to have to do that. So I'm going to use one of the problems from your review. You get to a point on number 32 on that review where you end up with 3 to the 5th times 3 times 2u, I'm trying to the 2u power equals 3 to the negative 15u power. Okay, so remember the things some of y'all did on the quiz is you decided, oh, guess what? I'm just going to cancel these out from, I don't know, made up math that you made up in some universe that is not this one. And then you just jump to this stuff down here. Big fat no. I don't want to see that. You're not canceling anything out. You also do not have a single exponential on both sides. You have to have that because that's what you would have to, that's the step you would have to be at in order to take the log of both sides. So I can combine those using exponent rules that we've known forever. So that becomes 3 to the 5 plus 2u power equals 3 to the negative 15u power. So now we have the one-to-one property, and that means that 5 plus 2u has to equal negative 15u, not because the 3's cancel out. Make sure you understand that. Now, if I was going to go through the log process, which I'm not saying you have to, I just want you to see how this works. Since the base of my exponential is 3, I would take log base 3 of 3 to the 5 plus 2u power is equal to log base 3 of 3 to the negative 15u power. And then this, nothing cancels out yet either. The exponents come out front, so I get 5 plus 2u times log base 3 of 3 equals negative 15u log base 3 of 3. And then at this point, this equals 1. So this whole thing here equals 1, and this whole thing here equals 1. That's why at this point we get to say that 5 plus 2u equals negative 15u. And then we go from there to solve it. And then, but we're allowed to go from here directly to here because the one-to-one property is basically saying that this kind of thing works every single time. I wouldn't have to do log base 3 of 3. I could have even taken, let's see. Not that you would want to do this, but I just want you to see that even here, I could have done log base 3 here. I could do log base 3 of 5 to the x equals log base 3 of 5 squared. So then when I bring these out front, I get x times log base 3 of 5 equals 2 times log base 3 of 5. Or it could have been a natural log, or it could have been the common log, it doesn't matter. But instead of saying, hey, these equal 1, and that's where I'm getting here, in this case here, I would just divide both sides by log base 3 of 5, which is totally legal. Right? And then these things cancel out. That's where canceling out happens, and that cancels out because I'm dividing, and then I still get that x equals 2. So it doesn't even matter what the base is, it just makes more sense to use the matching base because then it just equals 1. And then you get that x equals 2. You get the same answer either way. But that's what's happening. So yes, you are allowed to jump from here to x equals 2, but not because they cancel out, and you do not get to jump from here to here. That's a big fat no-no, so be careful on that. But that's the why behind it. Hopefully that makes sense.